So today we're going to finish up graphing exponential functions. So we're going to label your page 53, 15.4, graphing exponential functions. It's about time for us to go back and fill in your tab as well, because I forget. Exponential, couldn't spell it, functions. So we've got a foldable. You're going to need your calculator, as you can see, since I've got one on the screen. It's page 53. All right, so I'm going to go back. I haven't filled out them in a while. Remember, you were supposed to cross out the 5.3. We didn't do that one, and we're not doing that one. So we had 50 and 51, 52, 53. Tomorrow we'll do graphing quadratic functions, part of it, not all of it. All right, so I have a foldable. If you don't have one, you're writing on this page. Take it, fold it in half. Okay. Now, yesterday we talked about graphing these with a table, and I don't have a table, so I'm going to have to make one. I'm not going to just not graph, like, I have to have a table to graph these, okay? So I'm going to make a table out to the side here. X, Y, -2, -1, 0, 1, 2. Okay? All right. So just like yesterday, first I'm going to identify A. A is the first value, 4. B is 2. The x-intercept is always, well, not always, is none if it's not plus or minus. The y-intercept is A, 0, 4. In behavior, I'll have to determine. Domain will be all real numbers. Range, I'll have to determine. Okay, so let's get it graphed. So remember, I'm going to go to y equals. I'm going to type in 4 times 2. I'm going to raise it to the x power. Then I'm going to press second and graph. Okay, and I got to go up so I can see -2. So -2 is at 1, -1 is at 2, 0 is at 4, where the y-intercept is, 1 is at 8, and 2 is at 16. And I can actually graph all these this time. So -2, 1, -1, 2, 0, 4, 1, 8, 2, 16. Okay, graph, there we go. And now let's talk. Intercept, I did get that right. In behavior, when x approaches -infinity, y approaches 0. When x approaches infinity, y approaches positive infinity. And the domain is y, is all real numbers. The range is y is greater than 0. Because right here, it's going to start towards 0. It won't ever hit 0, so we don't have or equal to, and it's the numbers above. Okay. Throughout this lesson, you should pause the video between each one and do them on your own. Okay, so pause and do number 2, then play. Pause and do number 3, then play. All the way to number 6, because now they're all the same. All right. I'm going to just keep going. You pause when you need to. If I'm going too fast, pause. Okay, that's the point in it being in video this time. All right. A is the first value, B is the second. There's no plus or minus, so the x-intercept is none. Not in behavior, y-intercept is 0, 2, because it's the A value. In behavior, we'll have to figure out in a minute. I'm going to go ahead and draw this though. Okay, domain will be all real. Range will be y is something compared to 0. So we're going to make a table and figure it out. -2, -1, 0, 1, 2. Okay, clear this out. 2, it has parentheses this time, so we're going to use them. Alpha y equals gets us a fraction. 1 half, close parentheses. Oh, no, press delete. Go over. Delete. Then go over, close parentheses. Raise it to the x power. Second, graph. All right, we're going to get some fractions. It's okay, we'll have to graph this best we can. -2 is at 8. -1 is at 4. 0 is at 2. Y-intercept 1 is 1/2, 2 is 1/4. We'll have to just graph it the best we can. So negative 2 is at 8, negative 1 is at 4, 0, 2, 1, 1/2, so between there, and 2, 1/4, so about. Okay. In behavior, when x approaches the negatives, y is going up to positive infinity. When x approaches the positives, it's going towards 0. The domain is all real numbers because it goes left and right. The range is y is greater than 0 because it's the values above 0. Okay, number 3. A is 2, B is a third, no plus or minus, so it's none. The y-intercept is A. We don't know the end behavior. Domain is all real. Range is something compared to 0. So make a table. X, Y, I have no idea why I made that big. Okay. Y equals, clear this out, 2, parentheses, alpha, y equals, enter, 1, go down, third, go over, close the parentheses, and raise it to the x. Second graph. Negative 2 is 18. Negative 1 is 6. 0 is 2. 1 is 2/3. 3 is 2/9, which is going to be kind of hard to graph. That's close to 0.67 it is. And that is, I think, 0.22. I'm going to check. Well, I can check right here. I'm going to press second mode. I'm going to check by doing 2 divided by 9. Yeah, 0.22. I'm putting it in a decimal just so I can graph easier. Sometimes you need that just to graph easier. That's fine. Negative 2, 18. Negative 1, 6. This one drops pretty quick. 0, 2. 1, 2/3. 2.22. Just kind of guessing where the 2/3 and the 0.22 go. Okay. In behavior, when x goes towards negative infinity, y goes towards infinity. When x goes towards positive infinity, y goes towards 0. The range is y is greater than 0. Number 4. They are both fractions this time. 1/3, 1/4. The x-intercept, it does not have plus or minus, so it's none. The end behavior is 0, 1/3. The y-intercept, I accidentally think I said end behavior, which we don't know until we graph it. Domain is all real. Range is y is something compared to 0. Okay, so press y equals. Clear this out. We need a fraction first, so alpha y equals, enter, 1/3, go over, put parentheses, alpha y equals again, 1/4, go over, closing, raise it to x. Second graph. Oh, they're all going to be fractions. 5.3, repeating, 4/3, 1/3, 1/12, 1/48. We need to go to a calculator screen then because we are going to need to divide some of these. 4/3 is 1.3 repeating. 1/3 is 0.3 repeating. 1/12 is 0.083 repeating. And 1/48. These are just really close to 0 is what these are. Yeah. 0.0208. Okay, so let's graph these. So -2, going to go up to 5, and we're going to go a little above 5. -1, we're going to go up to 1 and go above it. 0 is 1/3, so at about a third. 1 is 0.08, it's close to 0. And 2 is even closer to 0. Okay, we're just really close to that line right there. It's going to be really close to 0. It's not going to cross. Remember, they don't cross. Okay, in behavior, when x goes towards negative infinity, y going towards positive infinity. When x goes towards infinity, y is going towards 0. And the range is y is greater than 0. Okay, last two, 5 and 6. A is -3. B is 1/2. There's no plus or minus, so the x-intercept is none. The y-intercept is 0, -3. We don't know the in behavior until we graph it. The domain is all real. The range is y is something compared to 0. If you haven't noticed, by the way, sometimes what they give you in the graph shows you what it's about to be, but oh well. X, -2, -1, 0, 1, 2. Y. Y equals, clear that out, -3. Alpha y equals, enter. Whoops. Okay. 1/2 raised to x. Second graph. All right, -2 is -12. -1 is -6. -3. -3/2. -3/4. And in case you need a decimal, it's -1.5. -0.75. That one's easier to do. Okay. -2, -12, -1, -6, 0, -3, 1, -1.5, and -2, -0.75. That one kind of looks like it's a flipped over. That's okay. It can be in any direction. Okay. In behavior, when x goes towards negative infinity, so does y. When x goes towards infinity, y goes towards 0. Domain is all real because it's pointing left and right. Range is in numbers less than 0. My screen froze, so make sure you get all that. Okay. All right. Last, number 6. I cannot see number 6. I'll fix it so you can. All right. Number 6. A is -4. B is 2. There are no x-intercepts because there's no plus or minus. The y-intercept is 0, -4. In behavior, we don't know yet. Domain is all real. Range is y is something compared to 0. Move that before I throw it down. Y equals, clear this out, -4 times 2 raised to the x. Second graph. Negative 2 is negative 1, then negative 2, negative 4, negative 8, negative 16. And it froze again. Okay. Let's graph. So negative 2, negative 1, negative 1, negative 2, 0, negative 4, 1, negative 8, 2, negative 16. Well, I didn't draw that great because I missed some of the points. In behavior, when x goes towards negative infinity, y goes towards 0. When x goes towards infinity, y goes towards negative infinity. And it is the values less than 0. Okay, that is all of graphing exponential functions. We're going to glue this in your notebook on page 53. 53. In case I didn't say any of the other videos, the geometric sequences we did last week and exponential functions are the same. All geometric sequences are exponential functions. Okay, there we go. And I will see you for the next topic soon.